The topic that we are going to cover in this slide is moment and equilibrium. So first of all, let's define the moment. I will say moment is a rotational acceleration. A force can perform many things, out of which the important things are it can accelerate an object. Acceleration is about change of direction or change of speed. The second thing that a force can cause is the deformation, a change of shape or size. The third thing that a force can cause is rotation. It is a change of rotational speed. So if we define moment, it is the product of force and perpendicular distance of line of action of force from the pivot. So basically moment of a force is product of two things. It is product of force. It is product of force and perpendicular distance. The perpendicular distance is the distance between the line of action of force and the pivot. For example, for certain rotations, if we want to define this moment of a force, then we should go with, for example, if this is a rotating wheel and a force acts here, for example, if this is a rotating wheel and a force acts at this point, then the moment will be defined as it is the product of force and the perpendicular distance. At this point, center of rotation is here, and this is the perpendicular distance. This is d. So if we multiply this f into d, if we multiply f and d, this will be the moment. So moment is the product of force and the perpendicular distance of line of action of force from the pivot. So this is the story of the moment. However, this perpendicular distance is important. Now let's suppose this is a door and it is pivoted here. The door is pivoted at this point. So this is the pivot of the door about which it will rotate. Let's suppose this is the point about which the door is rotating. This is the pivot. Let me change the color for the pivot. This is the pivot of the door, and this is basically this is the door. Now, if a force acts here to open the door, then for the calculation of the moment, what you have to do is that you have to take the perpendicular distance of the force from the pivot. The perpendicular distance of the force from the pivot would be, this is the perpendicular distance. For example, if examiner has given the length of the door or this distance d1, then I should clear that this d1 cannot be used. We have to use d2. The problem is that this d1 is not at 90 degrees to the force. We need the distance that is perpendicular. So always multiply the force with the perpendicular distance from the pivot. So in this example, the moment can be written as, we'll write moment is the product of force and perpendicular distance of line of action of force from the pivot. So this is the main thing. Let's solve some examples. Example number one. Example number one. A door of width, a door of width 2 meter is pivoted at one end and a force of 1000 Newton is applied to close it. So initially the door was open, you want to close it. So the door was, for example, it was here. The door was, for example, it was the door was at this position. When you apply a force on this door, for example, you are applying a force at some angle. Let's say you apply a force, you apply a vertical force here, and this force is making an angle of 60 degrees with the door. And this force has to bring the door here. And this line, for example, if this line is line AB, AB is the line where the door will be closed. Position at which the door, position at which the door closes. The door is closed. So this is the position at which the force wants to bring the door. And at the initial position, you see the force is 1000 Newton, and the distance that is given is the length of the door, width of the door, and this is 2 meters. And this is the top view. We are observing all of this from top view, and here this point is the pivot. To solve all the questions of moment, you have two options. Either take the perpendicular distance or resolve the force along the given distance. There are two options. We need to write that in problems of moment, you will always have, there are always two options. The first option is either draw a perpendicular from the pivot, to the line of action of, either draw a perpendicular from the pivot to the line of action of force, and then multiply the magnitude of the force, with the perpendicular distance, from the pivot. So One option is that draw a perpendicular, find the length of this perpendicular, and multiply this length with the force, and this will give you the moment. The second option is, or the alternate method is, instead of drawing perpendicular, the other method could be alternate method is draw the force, sorry, resolve the force, resolve the force along the given distance so that resolve the force along the given distance so that resolve the force along the given distance so that one component of the force is along one component of the force is along the distance while the other component of the force while the other component of the force is perpendicular to the given distance. Now the next step would be ignore the component of force that is along the distance. Ignore the component of the force ignore the component of the force which is along the distance and multiply the component of the force that is perpendicular, multiply the component of the force that is perpendicular to the distance and multiply the component of the force that is perpendicular to the distance with the given distance to find moment. Let's try to apply this. For example, the first method, first we'll apply the first method, then we'll apply the second method. Here the situation was you're given with the door. Let's apply the first method first. You are given with a door, and on this door, a perpendicular force is acting. Sorry, on this door, a force is acting at 60 degrees to the door. And what was the length of this door? The width of this door was 2 meters. The width of this door was 2 meters. This width here is 2 meters. And here you have pivot. And the force is 1000 Newton. We have only one problem here, that is the given distance and the force, they are not perpendicular. The first method is draw a perpendicular, find its distance, and then multiply the perpendicular distance with the force. For example, what I believe here, if you draw a perpendicular from the pivot to the line of action of force, I think this is perpendicular. So you have to draw a perpendicular from the pivot to the line of action of force. Say that is D. Say that is D. Now you have a right triangle in which the side opposite to 90 is 2 meters and D is to be calculated. So for the given triangle with 60-degree angles, D is either perpendicular, or you may call it opposite. You know about right triangles, it's like in A1, it's quite simple. So D is the opposite or the perpendicular. So if we apply this formula, sine of 60 is equal to D over perpendicular over H, that is 2 meters. So D would be 2 times sine of 60. Now if you use calculator, it would become 2 times 0.866, and the answer will become, if we multiply 2 into 0.866, the answer is, let me check the answer. They say it is 1.732, but let's confirm that. Let me get calculator here. So it is 2 into 0.866, and the answer is, as it was expected, it is 1.732 newtons. So this is the perpendicular distance and the force is 1000 Newton. So the moment would be, perpendicular distance is D and the force is 1000. And this perpendicular distance, right now we calculated it to be 1.732, and the unit should be, it should have been meter as it is distance. Now for the calculation of moment, we can multiply the given force, that is 1000 Newton, to the perpendicular distance, that is 1.732. And the answer would be 1732 Newton meter. The answer would be 1732 Newton meter, and Newton meter is the unit of torque. Now let's go with alternate method. Alternate method. Now instead of drawing a perpendicular, what if we resolve the force? We can resolve the force into two components, and for me, out of the two methods, I'm comfortable with resolving the force. So resolving the force is a bit easier rather than the other method. But first, you have to understand that. So for solving problems of moment in which force and distance are at different angles, one option is that draw a perpendicular from the pivot to the line of action of force, as we done in the first method, in the method number 1. The alternate method is that you should write, instead of drawing instead of drawing a perpendicular and finding the instead of drawing a perpendicular and finding the length of that perpendicular, the other method is resolve. So instead of drawing a perpendicular and finding the length of that perpendicular, the other method is resolve the force resolve the force along the given on the given distance. So resolve the force along the given distance. Ignore the component of the force that is so ignore the component of the force that is along the distance. Ignore the component of the force that is along the oscillation. So ignore the component of the force that is along the distance, and the perpendicular component should be multiplied with the distance. For example, here the second option was if this is the roll and this is the pivot, then we can also resolve the given force that would be this is the line of action of force, and the value of force that was given is how much force is given? The force is 1000 Newton. I think it was this question. The force is 1000 Newton. Now, if the force is 1000 Newton and you see force is at some angle to the distance, let's suppose the angle was 60 degrees. And this distance, let's suppose we call it d. However, the original value of this distance will be in this question. It is 2 meters. Now the second option. If we want to use this 2 meter, the option is that we need to resolve the force. The two components of the force, the point of action of force where the force is intersecting the object is the head of the force. So we have to resolve this force with the head and not with the tail. So if the point of action on the object for the force is head, then resolve from the head side, otherwise resolve from the tail side. Basically what I'm saying is that you have this force F. So F can be resolved in two methods. Let's suppose if you resolve with horizontal, if you resolve it with the horizontal, then it would become, if this angle is theta and you want to resolve it with the horizontal. The second option is, so this component is the component which is horizontal. This is F. And the vertical component will be, if this is theta, then this would be, obviously, this will also be resolved like this. So you can resolve the forces. This is F horizontal and this is F vertical. So when forces are given at some angle and the distance is not perpendicular, the other option is you can resolve the force. Now, if we resolve the force, this force must be resolved into two components. One component that is along the distance. One component that is along the distance, and the distance is 2 meters. Now, if we resolve the force of 1000 Newton on this 2 meter, then what we'll get is that the force of 1000 Newton can be resolved along the distance. This is the component along the distance, and this is the component perpendicular to the distance, and the arrows will be from tail to head or towards the head. So this component would become, is the perpendicular component, and this would be 1000 sine of 60. So one of the components is 1000 sine of 60, and the component with the angle will be 1000 cos of 60. We will ignore 1000 cos of 60 because it is along the distance. The one that is perpendicular to the distance is 1000 sine of 60. So whenever you have to calculate the moment, resolving the forces is better and it makes the question easier. So you can say that the moment can also be calculated as 1000 sine of 60 into 2 meter. So this moment will become 1000 sine of 60 is 86.66 into 2. So the moment will become 173.173. If we are not writing the decimal points even, then it is 173, and the unit is Newton meter. So this is the calculation of moment with resolving forces. So you have both the options. Either you can resolve the force, or you can resolve the distance, or you can draw a perpendicular from the pivot. However, if the examiner restricts a method, he can make a restriction like use resolution or use drawing the perpendicular method. So he can ask with any method to find the moment. Let's solve an example for this. Another example. An example related to this concept. Let's suppose you have a door which you want to open, and this is the door. Initially the door is horizontal, and the force that acts on the door, this force is 100 Newton. Now the angle, let's suppose, was, for example, it was theta. Then this 100 Newton will have two components. So if you resolve the force with respect to theta, it would become, so this force is F, and if we resolve F into its components, one of the components would be, one of the components that is here is called F. Okay, so F will be resolved into F cos theta, and the other component, this one, will become F sin theta. So the moment will be product of the force or the component of force that is perpendicular. So the moment will be the perpendicular component, that is F sine theta. So the perpendicular component F sine theta will be multiplied with the given distance. Let's suppose whatever this distance is, we should write F sine theta moment is equal to F sine theta times the distance will remain whatever it is given. The distance that we have to take is the given distance, that is 2 meters. In the start of the question, a distance was given. It is here. So the distance will be, the displacement will be, you will take the distance from the pivot. So all of this is written here as well. So the distance in our question was just 2 meters. So if you multiply 173 into 2, the answer would be 866 Newton meter. This is an example of calculation of moment, and this is the first topic of moment and equilibrium, while moment and equilibrium is the subtopic of force, pressure, density. We studied rational effect of forces or moment and equilibrium in the chapter force, pressure, and density. Here, up till here, we have to complete in this slide, and from here on, we'll start in the next slide. Take care, students.